Hello everyone. The aim of our video is to implement a 4-bit Johnson counter using a D flip-flop. First, I would like to tell you what a Johnson counter really is. A Johnson counter is a modified ring counter where the inverted output from the last flip-flop is connected to the input of the first flip-flop. The register cycles through a sequence of bit patterns. The mod of the Johnson counter is 2n if n flip-flops are used. The main advantage of a Johnson counter is that it needs only a half of the number of flip-flops compared to the standard ring counter for the same mod. It can be implemented using D flip-flop or a JK flip-flop, but we have implemented it by using a D flip-flop. It is a simple shift register counter. The flip-flops are arranged as in shift register, that is, the Q output of each state is connected to the D input of the next stage, but the Q bar output of the last flip-flop is connected back to the T input of the first flip-flop. Therefore, the name counter twister counter, also known as Johnson counter. To create a Johnson counter, we will be needing following apparatus. So the first apparatus that we need is a breadboard on which all the connections will be made. Then we will be needing a 10 k ohm resistor. We are also going to be needing 470 ohm resistors. Then the next thing that we require is a variable resistance, so we can change the value of the resistance whenever we want. Then a 9-volt battery, some connecting wires. Now the most important part that we need for creating a Johnson counter is the first part among it is two 7474 D flip-flop ICs. And also we are going to need a 555 timer IC for the clock. So this is the pin configuration of our 7474 D flip-flop IC that we are gonna use in our Johnson counter. Our whole Johnson counter is made according to the pin configuration of our D flip-flop IC. And this is the pin configuration of the 555 timer IC that we are gonna use in our clock. Friends, now I am going to show you how to assemble a Johnson counter on a breadboard. So here on this breadboard we have used two wires, as you can see, this one and this one. So we have to use these wires to connect the breadboard, as this breadboard is divided into two parts. So we will be needing four wires so that we can connect these two half breadboards together to assemble into a single breadboard. Now, the most important part that we are going to do is to connect the ICs on the breadboard. So the first IC we are going to be connecting is the 555 timer IC. As you can see, we are connecting it really hard so that it could not come out. The second IC which we are going to connecting is the 7474 D flip-flop IC. As we required 4 flip-flops and 2 D flip-flops IC, so now we will be connecting the second D flip-flop IC. As we've created a synchronous Johnson counter, so we know that we'll be needing a clock to count the pulses. So here we have created the connections of the clock according to the IC pin diagram, and my fellow mate will tell you about the connections of the clock. Hello everyone.
So, according to the pin diagram of 555 timer IC, the first pin of the 555 timer IC is given ground. Then we connect a capacitor. The positive end of the capacitor is connected to the second pin of the 555 timer IC, and the negative end is connected to the first pin of 555 timer IC. The output of the clock is given by the third pin, which is connected through resistor. A LED is connected, which shows us whether the clock is working or not. Then fourth pin is given as VCC. Fifth pin is left as it is. The second and the sixth pin of the 555 timer IC are interconnected, and the fourth and the eighth pin are interconnected, that is, they are given VCC. Variable resistor is connected to the sixth and seventh pin of the 555 timer IC, and a resistor of 10 k ohm is connected to the 7th and 8th pin. Remember that output given through LEDs is connected by a 470 ohm resistor. Now we will see how this clock is working. We will give VCC and ground. As you all see now, the clock starts to blink. That has started counting the pulses and giving the pulses.
As you can see that we have done the general connections of the two D flip-flops, and now my fellow mate will explain you what are these general connections.
The first thing that we do with an IC is to give VCC and ground to it. Here we have given VCC and ground to our ICs. Then second thing we must do is set clear and presets of all the ICs as one that is connected to the VCC.
So now as you can see that it is a Johnson counter, so we have connected the output of the last flip-flop towards the input of the first flip-flop, that is we have connected D1 to Q4 bar. Now in this step we have connected Q1 to D2, Q2 to D3 and Q3 to D4. Now, the most important step of making a Johnson counter to providing simultaneously clock to all the flip-flops. As you can see from the wires that we are showing that we have given 4 clocks. Now I'll make you count. The first clock is not the second clock, the third clock and the fourth clock. For the final step of our designing of the Johnson counter, I'll assemble the LEDs. Now, for assembling the LEDs, the most important part is that we connect it with a resistance. Because if you will not connect it with the resistance, then the LED will blow off when the clock or the pulse comes to it. Therefore, I have used the 470 ohm resistance for connecting the LEDs from the output. The output is connected from Q1, Q2, Q3 and Q4. Now I'll count you the LEDs. The first LED, the second LED, the third LED and the fourth LED. Now I'll connect the battery and show you how this Johnson counter finally works.